Good evening. We will wait for a couple of more people to join. So it's already 6:02. Hopefully we can start in within 1 or 2 more minutes.
Okay, sir. Sure.
Yeah. So if you have some specific questions, you can ask now because only you are there in the meeting now. So because I hope you were there in the like I solved this question previously because somebody asked about circular convolution in the last class. So I just wanted to repeat few questions and I just wanted to elaborate on circular convolution, and then I wanted to proceed with some questions related with linear algebra, some rank of a matrix, some linear independence related questions. So if you have some other specific questions, you can ask now, like some previous questions that we had solved in previous weeks. If you have some questions, I can solve that now.
Okay, sir. Actually, I have few questions, but those were like not were discussed in previous classes. So,
Okay.
can I share it to your email, sir? Can
Yeah,
if you
yeah,
could share your
yeah,
mail
yeah.
like
So related with which topic
for discrete Fourier series?
or discrete Fourier series? Yeah, I can solve that if you send me those things.
Yeah, yeah.
If more people join by then I will solve in the next class. Otherwise, I think already one person is joining. Yeah,
Okay, sir.
yeah, you can actually share the questions. Anyway, I will do that in the next week maybe. Yeah,
Oh, okay, sir. Sure.
yeah.
Thank you.
You know my mail ID, right?
No, sir.
Yeah, okay. My mail ID is uh, Krishnan K at iac.ac.in.
Okay, sir. Thank you.
Yeah. So if you share those questions, I can do in the coming class.
Okay, sir. Sure.
Yeah. I think there is only one more week before the gate exam, right?
Yeah.
Okay. Okay. Anyway, we will wait for 1 more minute and by 6:05 we will start. Now only 4 people are there in the meeting. Yeah. So I think some of you have asked to do some questions related with circular convolution and linear convolution. I will do 1 or 2 such questions. This one question is very simple. I think I have solved this question in one of the previous sessions, but the next question is a question that I haven't done before. I don't know whether somebody else have done that or not. Okay. Anyway, we will start. Hopefully, more people will join by then. Okay. So first of all, I hope all of you know about discrete Fourier transform or DFT. So I just wanted to make a connection between discrete Fourier transform and circular convolution. Okay. So first of all, uh, like we will take two discrete time signals. Discrete time signals means it's a vector of real numbers. It can be of complex numbers as well. But let us consider only real valued signals. So we will consider real valued discrete time signals. For example, say x of n equal to say 1, 2, 1, 1. So the length of this sequence or the length of this discrete time signal is 4. And if I mark something similar to this, or if I don't mark anything, then the first position corresponds to n equal to 0. So x of 0 equal to 1, x of 1 equal to 2, x of 2 equal to 1, and x of 3 equal to 1. So this is what this signal x of n equal to 1 2 1 1 means. Okay, I just wanted to set this platform. So uh, the first thing is linear convolution. So the linear convolution has some operational significance in the sense that this linear convolution has to do with polynomial multiplication. Okay, so how does that come? So if I have, say, if I need to convolute two signals, uh, x of n equal to say 1 to 2, and say h of n equal to say uh, something 1 3 1 or something. Okay, then x of n convoluted with h of n, this stands for normal convolution. Okay, if it's a circular convolution, I will put a circle around that. So this corresponds to, in fact, it corresponds to the coefficient of the product of these two polynomials. Okay, x square plus 2x plus 2 into x square plus 3x plus 1. So basically here you can see the coefficient of x square is 1, that is this one, and coefficient of x is 2, that is this 2, and coefficient of x power 0 or the constant term is 2, that is this 2. Okay, similarly the second polynomial x square, the coefficient is 1, that is this 1, and 3x, that 3 is this 3, and this 1 is this 1. Okay, so if I take the product of the polynomial, what will be the degree of that resulting polynomial? That will be 4, right? So I can quickly do the multiplication. X power 4, 3x square plus x square, sorry, 3x cube plus x square plus 2x cube plus 6x square plus 2x plus 2x square plus 6x plus 2, right? I think I haven't made any mistake. So this is equal to x power 4 plus 3 plus, so here I have 3x cube, here I have 2x cube. So in total I have 5x cube, and I have x square, 6x square, 2x square. So in total I have 9x square, right? I hope it is correct. So x cube, yeah. So then I have 8x. So here I have 2x and 6x plus 2. So now if I collect the coefficient 1, 5, 9, 8, 2, then this has to do something with the convolution. That's what I'm going to show you. Okay, first of all, how is linear convolution defined? You can see this equation. This is the equation for finding the circular convolution between two sequences x of n and h of n. Okay, so if I have a sequence x of n which is of length n, okay, and I have another discrete time signal h of n which is length m, then the length of x of n convoluted with h of n will be n plus m minus 1. Okay, so yeah, now how can we do this convolution very easily? So the in textbook or maybe in class you might have seen a lot of techniques like flipping the signal and doing a lot of stuff, but today I will like show you an easy method, not very easy method, but it's a like it's a nice way of doing that. Okay, let me reproduce the signals x of n and h of n here. So x of n equal to 1 2 2 and h of n equal to 1 3 1. Okay, then how will I convolute this? So I can use that formula, obviously that is a different case, but now I will show you some other way of doing this. So I will write I will essentially make a 3 by 3 matrix now. 1 2 2 I will write at the top, and 1 3 1 the second signal I will write at the left side. So now what I'm going to do is that I'm writing the product corresponding to every term. Here I will write 1 into 1, that is 1. Here I will write 1 into 2, that is 2. Here I will write 1 into 2, that is 2. Here I will write 3 into 1, that is 3. Here 3 into 2 is 6. Here 3 into 2 is 6. Similarly, 1 into 1 is 1. 1 into 2 is 2. 1 into 2 is 2. Okay. Now what will I do? Now the thing is that now, so I will take the sum of this, that is 1, right? There is only one term, that is 1. Now I will take the sum of these two. What is that? That is nothing but 2 plus 3, that is 5. Next I will take the sum of these diagonal, off diagonal basically. 1 plus 6 plus 2 is nothing but, what is that? 9, right? Now next I will take this sum, 2 plus 6, that is 8. And finally this one, that is 2. So what is that I got? 1 5 9 8 2. That is precisely the linear convolution between x of n and h of n. So now you can see what I got here as the product of polynomial multiplication. That is precisely 1 5 9 8 2, right? And that is same as what we got. So basically this linear convolution has an operational significance in polynomial multiplication. That is what I wanted to tell you. Okay, now yeah, also it has, obviously it has a significance on LTI systems. So if there is an LTI system, that has an say discrete time LTI system, okay, which has an impulse response or h of n, and if the input signal is x of n, then the output y of n will be the linear convolution of x of n and h of n. Okay, so in terms of signal processing, this is the significance of linear convolution. Hope it is clear up to this point. Now we will see what is the significance, or how can we find out circular convolution. Okay, so now, yeah, so circular convolution actually comes from the Fourier representation of signals. So if I do some operations on signals in the Fourier domain, that means in the frequency domain, what is the corresponding thing that is happening in the time domain or discrete time domain? That is what is circular convolution. I will come to that. If in the continuous signal case, so continuous signals means x of t and h of t, where t is a continuous, it's a time is a continuous thing, right? It's not discretized one. So previously when I refer x of n or h of n, that's a discrete version of the signal. When I refer x of t or h of t, that's a continuous signal. So if I have an LTI system, a continuous time LTI system which has an impulse response h of t, and if the input is x of t, then the output is y of t, which is equal to x of t convolution with h of t. So in continuous domain, the definition of convolution is slightly different, that you may be knowing. So yeah, in this case, if I have the frequency domain representation, that means if x of omega is the Fourier transform of x of t and h of omega is the Fourier transform of h of t, then y of omega is nothing but x of omega into h of omega. Okay, so basically in time domain, the signals are convoluted, but in frequency domain, we have multiplied the corresponding Fourier transforms, right? So basically the same signal I'm representing in time domain as x of t and representing as x of omega in the frequency domain. So in one domain, I'm multiplying two signals, x of omega and h of omega in frequency domain. At the same time, that operation corresponds to linear convolution in time domain, right? Agree? But when we go to discrete time signals, if I take discrete for, say I have a x of n and I have h of n, if I take the discrete time, sorry, not discrete time, discrete Fourier transform or DFT, suppose x of k is the DFT of x of n and h of k is the DFT of h of k, sorry, h of n. So x of k into h of k in the discrete frequency domain, this operation corresponds to what operation in the discrete time domain? That is the question. That is not linear convolution. That is in fact circular convolution. That is the significance of circular convolution. Okay. So if I have two signals in discrete time signals, if I take the endpoint, the same, the DFT it's usually endpoint DFT, right? So endpoint, that's what we call endpoint DFT. So x of k, I will write the equation x of k equal to summation n equal to 0 to n minus 1 x of n to e power minus j 2 pi n by n into k. This is the discrete Fourier transform equation, right? So this capital N, that's the length of the signal x of n, that endpoint DFT, the product of that in the frequency domain, how does that manifest in the discrete time domain, or what operation in the discrete time domain corresponds to the multiplication in the frequency domain? That is the question. So the answer to that question is nothing but circular convolution. Now, how do circular convolution and linear convolution related? Okay. Before that, we will see the definition for circular convolution. So here you have seen why linear convolution equal to h of m into x of n minus m, summation over m equal to minus infinity to infinity. Now we are considering signals h of m, h of n and x of n, which is of length n. If they are not of equal length, then I will zero pad. Okay, whichever signal is having the shortest length, we will add remaining zeros and make the signals are of equal length. That's the first thing that we need to do. And after that, let capital N be the length of the signals x of n and h of n. Then the circular convolution equation is this. Okay, so here if you see, so first of all, forget about this limit of the summation that comes from the infinite length of the signal. If I restrict the length of the signal to be n, then it will come in the same way. But the main difference comes here. Here I have x of n minus m, but here I have something else. Correct? N minus m mod n. This means n minus m mod n. What does that mean? You know modular arithmetic, right? For example, what is 10 mod 3? That is nothing but 1. So what I will do, I will divide 10 with 3 and I will take the remainder. So 10 by 3 is 3 and 1 by 3. So this one is this one. Okay, the remainder after the division. Okay, so here n minus m mod n means, what does that mean? If it's a negative number, I have to add plus n. That's what is happening there. Anyway, now I will come to the equation later. Now I will tell you how can we find out the circular convolution of two sequences. So 3, I'm not going to use the equation. I will show you again how can we calculate that circular convolution using this same table. In some way you can find it out. Basically what you need to do is that, so here I have take some one in linear convolution, right? That one is this one. So now instead of that, I will take sum of this and this. So I am taking the sum of three numbers, 1, 2 and 6. So that is nothing but 9, right? That is 9. Then the second sum, what I am doing is I am taking the sum of this and this. Okay, so now what is that sum? 3 plus 2 is 5, 5 plus 2 is 7. And finally what I am doing is that I am taking the sum of these three. Okay, now I am always taking the sum of three numbers, that you have to be very careful about. So here the sum is 9. So basically the circular convolution of these two sequences will result in this signal 979. Okay, or from the linear convolution, how can we do that? You can take this 8 and 2 here and you can write 8, 2 here and you can take the sum. So basically 1 plus 8 is 9 and 5 plus 2 is 7 and this 9 will come as it. Is it clear? Any questions? So if you want, I can do one more example. So let us go for a 4 length sequence. Yeah, anyway, next question is related with that. So we will do that. Is it clear up to this point? If you have some confusion or if I'm going so fast, you can tell me. I know I'm going a little bit fast, but I think this program demands that. Okay. Do you have any questions? Okay. Anyway, we will do one more example as the first question. Okay, this is a question I don't remember from which year. Anyway, appeared in after 2014, I guess. In some year it appeared. It's a pretty straightforward question. Okay, so I have two real sequences, x1 of n and x2 of n, as shown here, x1 of n and x2 of n, and I am taking 4-point DFT. Okay, then what I am getting is x1 of k and x2 of k. They are nothing but DFT, discrete Fourier transform of these two signals respectively. Okay, then what I am doing is that I am taking the product of x1k and x2k. That means I am multiplying those two signals in the discrete frequency domain, and I am obtaining a new signal x3 of, okay. And finally, I am taking the IDFT, that means inverse. So how to take circular shifting? Circular shifting means, okay, anyway, after this question we will discuss that, okay. Yeah, so x3 of k I have obtained. Basically I have x1 of n, I have x2 of n, I have taken DFT, 4-point DFT, and I got x1 of k, and I took 4-point DFT here, and I got x2 of k, okay. Now I am obtaining another signal x3 of k as x1 of k into x2 of k, and finally I am taking the IDFT of x3 of k, and I'm obtaining x3 of n. So essentially, from the previous explanation, I can write x3 of n is nothing but the circular convolution between x1 of n and x2 of n. Is it clear? Any questions regarding this? Okay. So yeah, now it is asked to find out the value of x3 of 2. First of all, let us find out x3 of n completely, even though it is not required as far as the problem is concerned. We just need to find the value of x3 of 2, okay. So I have 1 2 3 0 and 1 3 2 1. 1 2 3 0, this is the first signal, and the next signal is 1 3 2 1. So I will write it as in the previous case, 1 2 3 0 1 3 2 1. So now I will take the product, okay, and I will fill all these columns. So this is 1, I will do it quickly. 1 2 3 0 3 6 9 0 2 4 6 0 1 2 3 0, okay. If I wanted to find out linear convolution, I could have written very easily 1 taking sum of these 2, then I will get 5. Sum of these 3, I will get 8 11, and if I take sum of these, I will get how much? 14. Then I will get 8 3 and finally 0, okay. Now if I wanted to find out, anyway we need to find out the circular convolution, right? So that I can find it as follows, okay. So I think you are referring to this shifting, right? I will explain this, okay. So yeah, first I am considering this off diagonal thing, and the first off diagonal after the main off diagonal. So main off diagonal means you will have 4 entries here, 1 4 9 0, okay. And the one just beneath or just under that off diagonal is 260, right? So you need to take the sum of these 4 entries, 1 2 6 0, that is nothing but 9. And next I need to find the sum of this 2 and this 2, okay. What is that? 3 plus 2 is 5, 5 plus 3 is 8. And next I need to take this 3 and the last one. So 263 is nothing but 11, right? And finally you will have to take this. So that is nothing but 14, right? So the this is x3 of n. So this is x3 of 0, and this is x3 of 1, and this is x3 of 2, and this is x3 of 3. So we need to find x3 of 2. So the answer to the question is 11. So again, coming back to this linear convolution, now I have 1 5 11 14, right? So this is the first half basically, and you need to take the remaining 3 and you need to write it like this, and you can just take the sum 14 11 8 9. So that is precisely we got here, right? This is equal to this 9 8 11 14. Is it clear? Any questions? Shekhar, can you repeat your question? I did not get it clearly. If you can unmute and you can talk, that would be better. I did not clearly understand understand your question, I guess.
So
Circular.
like hello.
Yeah, yeah. Go
So
ahead.
like if we take shifting in time domain like left or right, that type of in circular,
That type of in circular means.
circular shifting like
So you're not referring to circular convolution. Are you referring to something else? In the sense that are you referring to like just shifting in the time domain? How does that come in the frequency domain? Is that what you're asking? Did you get my question? Hello? Did you get my question? Can you clarify that? Yeah, Ramesh. Yeah, go ahead.
Sir, can you explain the circular convolution once again, sir? That 9, 8, 11, 14, how it came?
Haha. So basically, so you understood how did I write this table, right?
Ah, yes, that I know.
Yeah, yeah. So basically, one way is to just apply that equation straight away. But the problem with that writing the equation is that you may miss out something. If you miss some term, the entire thing will become different, right? So this is one way of doing that. That's it. Okay. So the now the thing is that so basically, I hope you understood how can we get this linear convolution, right?
Yeah, that I know, sir.
Yeah, okay. Now coming to the circular convolution, the thing is that basically here in linear convolution, I took the sum of this, then this, then this, then this, then this, then this, then this, right?
Yes,
So instead of that, here basically if you see that equation carefully, you will come to know that you need to take the sum of four number like product of n in the sum always there will be n terms here in linear convolution. Here there is only one term, here there are sum of two terms, here the sum of three terms, next sum of four, sum of three, sum of two, sum of one, right? It comes up and it goes down. That's how it happens. So I'm talking about the number of entries to be summed up. Okay, so here when it comes to circular convolution, you're always summing up four terms or n terms in general. Okay, so here, so what are those n terms? That is what I'm telling. So one, so the last term will be definitely this one. Okay, the last term in the nth term in the circular convoluted answer or in the sequence. In case x3 of n, the last one that will be this off diagonal, the main off diagonal. Okay, so that is that position you fix. So that sum corresponds to 14 in this case, right?
okay, sir.
Yeah. So the next method, then we will start from the zeroth position, x3 of 0. How do we find out that? So go here, that is the first one, right? So that is the topmost or off diagonal, right? So here, then go down. So now you have four uh, elements. So you need to take these four. You can't take any random four numbers. You have to take this four itself. Okay. So
So how did we arrive at this these four, sir? Any method of
yeah.
that?
No, oh, if you want that, then I'm just telling this as a method to do circular convolution. If you want, I can explain that from the equation. Okay. From equation, I can tell you how do we arrive at this. That I will come. Okay. So anyway, since you have asked this, so this is the equation. Okay. So you see this equation. I will write it again in the again. Okay. I hope you have seen this.
Yes, sir, I'm
Yeah.
seeing.
So yeah. So y of n equal to, I will change the color, y of n equal to summation m equal to 0 to n minus 1, okay, h of m into x of n minus m into m, n, okay. or I'll write it as mod n itself. I don't want to confuse you. So this is mod n, right? So let us apply y of 0. How do we get that? Y of 0 is nothing but summation m equal to 0 to n minus 1, okay? H of m into x of n is 0, right? Minus m mod n. Is it clear? There is nothing like fancy in this. Straight away I'm substituting n equal to 0. So minus m mod n is nothing but minus m plus n. If you want, I can show this like minus 3 mod 5, for example. Minus 3 mod 5 is nothing but, this is 2 basically. How am I getting this? Minus 3 can be written as minus 1 plus 2 by 5, right? Not minus 3 by 5, not minus 3. I can write like this, right? Minus 3 by 5 is minus 1 plus 2 by 5. Agree?
Yes, sir.
Yeah. So minus 3 mod 5 is nothing but 2. Agree?
Yes.
Yeah. So in general, for any m, any positive integer m less than n, okay, minus m mod n is equal to minus m plus n. Okay. So in this example, let us go with this example itself. Okay. So here, so I have n equal to 4, right? So y of 0 equal to m equal to 0 to n equal to 4, 3 h of m into x of minus m mod what? Mod 4, right? So basically, I will expand this sum. Let us substitute m equal to 0, h of 0 into x of 0 mod 4 is nothing but 0 itself. So x of 0, okay, plus h of 1, okay, x of minus 1 mod 4 is nothing but x of 3, correct? Plus h of 2 into x of minus 2 mod 4 is 2, x of 2, and finally h of 3 into minus 3 mod 4 is 1, so x of 1. Okay, so now if you go to the table, if I call it as this, suppose this is x of n and this is h of n, okay, then you can see the first term is h of 0 into x of 0. That is nothing but this term, h of 0 into x of 0. Now if you see h of 1 into x of 3, what is h of 1? So h of 1 is nothing but, h of 1 is what? H of 1 is, where is h? H of 1 is 3, right? And h of 1 and x of 3 is nothing but 0. So this is that term, correct? H of 1 into x of 3. The next term is h of 2 into x of 2. So this is h of 2 and this is x of 2. So h of 2 into x of 2 is this term. And finally, h of 3 into x of 1. So this is h of 3 and this is x of 1. Agree? So that product is this. So I am essentially taking the sum of these 4 to find out y of 0. Is it clear? Ramesh, is it clear?
Yeah, yes, sir. Clear.
Yeah. Okay. Yeah. So now let us go to the next question. Okay. So I hope the question is clear. Now let us come to this question. So this question, yeah, it is as follows. Consider two 16-point sequences x of n and h of n. Let the linear convolution of x of n and h of n be denoted by y of n, while z of n denotes the 16-point inverse discrete Fourier transform IDFT of the product of the 16-point DFTs of x of n and h of n. The values of k for which z of k equal to y of k. So basically, I have x of n and h of n, and y of n is nothing but x of n linear convoluted or convoluted with h of n, and z of n is circular convoluted with x of n and h of n, right? That's what is happening. I am taking DFTs, I am multiplying, and finally I am taking IDFT. So in time domain, it corresponds to circular convolution. Agree? So I have y of n, or yeah, they are denoting it with h of n, and while z of n denotes 16 point IDFT of the product of the 16 point DFTs of. Okay, so they are denoting it with y of n and z of n. Exactly. Okay, now we need to find the values of k for which y of k equal to z of k. So can somebody tell the answer from the previous? It has to be true in all the cases. Okay, so it is very straightforward. If you see the previous that table method of finding out linear convolution and which one, circular convolution. Can somebody tell the answer?
C.
Okay, k equal to 15. That's correct. Answer is correct. So is this clear for everyone? Okay. Is it clear? Okay, anyway, so if you see in the previous case, so here, so this 14 remained the same, right? Irrespective of whatever be the signal x of n and h of n, this point will remain the same. It will not be 14, but it corresponds to this off diagonal, correct? And that will come as the last entry in the circular convolution. Agree? So this will be the same, both in the case of circular convolution and in the case of linear convolution. So the answer is when k equal to n minus 1. K equal to n minus 1. Here n equal to 16. So k equal to 15. So the answer is 15. Anyway, I will give one more explanation for that question. Okay. So I will write the equation for z of n, that is the circular convolution, which is equal to summation. Circular convolution is summation k equal to, sorry, m is the variable that I was using, right? M equal to 0 to 16 in this case, n. So 15, n minus 1, h of m, correct, into x of n minus m mod capital N. So in this case, n is 16. Or in general, I can write it as n minus 1 itself. Then later I will come to the answer. Okay, mod n. So I can split this like this. Summation m equal to 0 to n, okay, h of m into x of n minus m mod n. So whenever m is in between 0 and n minus m will be always greater than or equal to 0. Correct? So mod n will be the same in that case. Plus summation m equal to n plus 1 to capital N minus 1. I am splitting that h of m into x of n minus m mod n. So that will be n minus m. That will be negative, right? N minus m will be a negative number. So in that case, mod n will be n minus m plus n. Agree? So this is, if you forget the limit, this term corresponds to the product term in the linear convolution, right? So basically, when n equal to n minus 1, this term won't be there. This will be completely this term. And this summation will be equal to summation m equal to 0 to n minus 1 h of m into x of n minus m. Correct? So this happens when n equal to n minus 1, or y z of n minus 1 equal to this. Correct? So this is nothing but the circular convolution. So here I have to substitute n equal to n minus 1 minus m. So this is nothing but y of n minus 1, or linear convolution between x of n and h of m at small m equal to n minus 1. So at k equal to, in this question, when k equal to n minus 1 means k equal to 15, circular convolution and linear convolution would be the same. Is it clear? So the answer is C, k equal to 15. Clear? Or any questions? Independence. Okay. Any questions so far? Okay. I guess I can go ahead. Okay. Now this is a completely different question. If you are comfortable with this question, then we will move to the next question. So is the question clear? If the vectors 1, minus 1, 2, that is the first vector, second vector 7, 3, and x, and 2, 3, 1 in R cube are linearly dependent, then the value of x is. This is a numerical answer type question. Okay. Is it okay? Anyway, let me do this. So first of all, what is this R3? R3 means it's the set of all the vectors. Say I will write it as x1, x2, x3, such that all these x1, x2, and x3 can take any real values. Okay. So this R stands for real values. So yeah, x1, x2, x3 can be any real value means basically I'm representing the three-dimensional world. This x1, x2, x3. Okay. So what is linear independence? What is the definition of that? If vectors v1, v2, v3, etc., vn, okay, if I equate this summation ai times vi, I equal to 1 to n, equal to 0. If I do this, and if this has only one solution, a equal to 0 for all I, then I will tell that all the vectors are linearly independent. If not, if there is a non-trivial solution for this, then I will call those vectors are linearly dependent. Okay. So I don't want to get into these complications. For this question, you have given three vectors, right? v1, which is equal to 1, minus 1, 2, v2, 7, 3, x, and v3, 2, 3, 1, right? So what does linear dependence? It is told that are linearly dependent. We need to find the value of this x such that these three vectors are linearly dependent. Okay. So linear dependence means, so if I take, say if I take v2, then I should be able to write v2 as a times v1 plus b times v3. Okay. So basically I am multiplying the first vector. Multiplying the vector means I am multiplying with a scalar number. That means I am multiplying every entry, each entry in the vector v1 with a. Basically, I am scaling that vector, correct? I am scaling the vector v3 as well with a coefficient b. Okay, then I am taking the sum. This is known as the linear combination of vectors. I am linearly scaling them, and I am taking the product. No, not product. I am taking the sum of those two scaled vectors, correct? So this is known as the linear combination of v1 and v3. If I can write v2 as the linear combination of v1 and v3, then they are linearly dependent. So we need to find now a and b. If we can find such an a and b such that v2 is equal to a v1 plus b v3, then we can find the value of x as well, right? Okay, let us proceed. So what is a times v1 means? So a minus a, 2a, right? So this is a times v1, and b times v3 is nothing but 2b, 3b, and b. So V2 is 7, 3 and x. So this is equal to a plus 2b. So I'm taking sum of these two. It's a element wise addition. So minus a plus 3b, 2a plus b. Correct? So I know, so these two has to be equal, right? Then only they will be linearly dependent. So then I can write a plus 2b equal to 7 and minus a plus 3b equal to 3. So let us solve this. It corresponds to 5b equal to 10. Correct? I am adding those two. That means b equal to 2. If I substitute b equal to 2 here, then I will get a equal to 3. Correct? Is it clear up to this? Then what is the value of x? X equal to 2a plus b. So 2 into 3 plus 2. Correct? So the answer is 8. Any questions? Is it clear? Or should I explain something again? Is it clear? Okay, wait. Okay, then let us proceed to the next question. Yeah. So I have two options. You tell which one should I do. Okay, either I will do this question. Okay, so this is question number 4, or I will do this question number 5. Which one do you want? I hope you can see this, right? The rank of a matrix you need to find out. In this question, in the other question, there are 4 statements given and you need to determine which one is false. So whichever you want, I can do. I think this question I have solved long back in the phase 1 of this gate and TTL thing. So whichever question you prefer, I can do that. So I think I have only time. This question you want, or the other one, Gobinath? This one,
So
right?
this question.
Yeah, okay, great. Okay, so yeah, basically this is more of like an abstract definition level question. Okay, so here the question is as follows. There are 6 vectors given, v1, v2 up to v6. 6 vectors in R power 4. That means 4-dimensional real space. So previously we have seen a 3-dimensional thing, right? Those vectors were in R3, correct? R3 means the length of those vectors will be 3 and all the entries will be real numbers. So regarding these 6 vectors, 4 statements are given, and out of the 4 statements, 1 statement is wrong or false. We need to determine that one. Excellent. The answer is option C, as somebody have already told. Okay, so the options are as follows. It is not necessary that these vectors span R4. These vectors are not linearly independent. Any 4 of these vectors form a basis for R4. If v1, v3, v5, v6 spans R4, then it forms a basis for R4. Okay. I hope these terms, linear dependence, independence, span, basis, those terms are not alien to you. Okay, I'm going to explain these things on that basis, okay, on that background. Okay, yeah. So there are 6 vectors given. So first of all, I will start with something very simple. So R2 means what? It's this, I can simply write this xy, right? So this plane, basically xy plane. So this is some point x comma y, right? This x can be any real number, y can also be any real number. Depending on that, this position will change. For example, yeah, this is one possibility. This may be say 2 comma 1. So here it can be say minus 3 comma minus 1, something of that sort. It is possible, right? or maybe here something 0.5 comma 0.5 comma minus 0.5. Lot of possibilities are there, right? This is basically R2. So I can draw R3 as well, maybe using some slanted lines, something like this. I can draw R3, but it is not possible in general. It's a 2D plane, right? The screen that you're seeing is a two-dimensional plane. So you cannot draw R3 completely, but R4 you can simply imagine. So how do we imagine R4 first of all? So basically you can imagine this as a vector, F4 tuple A, B, C, D or something. All these numbers can be any real number. A can be any real number, B can be any real number, C can also be any real number, D can also be any real number. Okay, first of all, so coming to two-dimensional plane. Okay, so first I will explain what is spanning. Okay, so if I take only one point xy, then this is the vector, right? So that corresponding vector is this. Correct. So I will, instead of xy, I will write some pq. So this is the vector pq. Okay. So what is the span of this vector? So that is basically this line. What does that mean? First of all, so if I have this vector pq, so vector means that joins between 0, 0 and pq. Okay. So that vector can, if I shrink that vector or if I expand that vector, but I cannot change the direction, okay, then I can reach anywhere in this line, right? If I expand or if I compress that vector, I can reach anywhere in this plane. Do you agree with that? Instead of that, if I take one more vector here, some other vector, some r comma s, okay, if I take such a new vector r comma s, then so now what I'm doing is that I'm taking the linear combination. So I can expand both these vectors and I can add those expanded or compressed vectors. Basically using this, I can reach anywhere here, and using this, I can reach anywhere here, right? And if I take some, you can reach anywhere in this plane. Do you agree with that? Except under one condition. What is that condition? That condition is very simple. This vector r comma s is not reachable from p comma q. Not reachable means by expanding or compressing that vector pq, you should not be able to express rs. Or in other words, rs should not be in this line. If rs is in the same line as the vector pq that forms the line that is formed by the vector pq, then you cannot reach anywhere in R2 using PQ and RS. You can still be only in that line. But if RS is somewhere outside that line, then by combining these vectors PQ and RS appropriately, that means combining means taking the linear combination of these two vectors, I can reach anywhere in the R2 plane. For example, I will take very simple example, 2 points. Okay, the first point is here, 1, 0. The second point is 0, 1. Or these are vectors, not simply points, 1, 0 and 0, 1. So I want to reach somewhere, say 5.1, 10.7. Can I get this vector as the linear combination of these two vectors? It is possible, right? If I call this as v1 and if I call this as v2, vector v1 and vector v2, then this new vector v3 is simply 5.1 times v1, correct, plus 10.7 times v2. Agree? That is the case, right? Yeah. So that is how it comes. So basically, if you have two points, or if you have two vectors, okay, now I'm changing from points to vectors. If you have two vectors in the R2 plane, then you can reach anywhere in the R2 plane, provided that those two vectors are not linearly dependent. Okay. if I have, as I have told previously, this and somewhere in the same line as this vector, maybe here, these 2 points, if I consider as v1 and v2, then you cannot reach. In that case, they are linearly dependent, right? Linearly dependent means I can scale and compress and I can reach in the other point. So they are linearly dependent. If you take any two linearly independent vectors in R2, you can reach any point in R2. Okay, in this case 0 1 1 0. Is that clear? So in other words, if you have two linearly independent vectors in R2, you can span R2. Okay, you can reach anywhere in R2 means you can span the entire plane. Okay, that is the meaning of the word span. So you can write any point, any vector in R2 as the linear combination of two linearly independent vectors in R2. In this case, 0 1 and 1 0. You can write any, so if it need not be 0 1 and 1 0. Okay, it can be, so these two vectors, right? They are not in the same line. They are in a different line, or they are linearly independent in this case. Correct? But if you take a third vector in the R2, so I have 0 1 and 1 0. If I take a third vector in the R2, okay, you can write that point, that vector, okay, that vector maybe 5.1 comma 10.7, that vector as the linear combination of 0 1 and 1 0. Agree? Or in other words, v3 falls in the span of v1 and v2. Agree? v3 falls in the span of v1 and v2. In this case, 5.1 comma 10.7 falls in the span of 0 comma 1 0. Everyone agree with that? So if I extend this idea to maybe some other higher dimensional spaces, vector spaces, in fact, okay. So in R3, you can have maximum of 3 linearly independent vectors. You cannot have a fourth vector such that all the 4 vectors are linearly independent. That is not possible in R3. But when you go to R4, you can have 4 linearly independent vectors, correct? Such that those 4 vectors span R4. Using those 4 vectors, you can reach any point in R4, provided that all those 4 vectors are linearly independent. So basically, you cannot express one out of those 4 points as the linear combination of the remaining 3 vectors. If that is not possible, then we will tell those 4 vectors are linearly independent. Agree? Okay. Now comes to basis. So basically, if you have two linearly independent vectors in R2, then use the entire R2 plane is the span of those two vectors, right? Agree? Then we will tell that those 2 points form a basis for R2. Okay, so basis is nothing but the minimum number of vectors, not the number. So minimum vectors, those are needed to span R2 or a vector space. Okay, so now come to the question. In R4, there are 6 vectors, v1, v2, v4 up to v6. But in R4, you see, you can have maximum of 4 linearly independent vectors. If I have a fifth one, I can definitely express the fifth one as the linear combination of the first 4, provided that the first 4 are linearly independent. Okay. Now, yeah, the question is option A. It is not necessary that these vectors span R4. Is it correct? In fact, it is correct. In R2, if you see 1 0 and 2 0, if you take those two vectors instead of 0 1, okay, then those two do not span R4, right? That can span only this line. If you take any more vectors that falls in the same line or in the same x-axis, maybe 2 0 3 0, if you take all those vectors, you will be still in the same line. You cannot go to maybe some other point in R2, correct? So it is not necessary that these vectors span R4. So those 6 vectors span R4 only if there are 4 linearly independent vectors out of those 6. Correct? These vectors are not linearly independent. That is true because you can have maximum of only 4 linearly independent vectors in R4. You cannot have 6 linearly independent vectors in R4. So option B is also correct. So now coming into option C, any 4 of these vectors form a basis for R4. It is not true. You have seen, right? Here in this case. So 1, 0 and 2, 0 in R2 cannot form a basis because those 2 vectors cannot span R2. Okay. Now, if V1, V3, V5, V6 spans R4, then it forms a basis for R4. Correct, right? Because you can reach any point in R4 using these 4 vectors. Correct? Then it forms a basis for R4. Agree? Is it clear? Any questions? Any questions? It's already 7. If you have some questions, you can ask now. Okay. So basis is in fact the minimal spanning set. Okay. Suppose you have 1, 0 and 0, 1. So this will definitely span R2, right? So that you have seen already. So if I take one more point, say -2, 1, okay? If you take these 3, still these 3 can span R2, correct? But these 3 do not form a basis. Basis means you have to have only 2. So if you take these 2, this will also form a basis. If you take these 2, this will also form a basis. Okay? So basically basis is the minimal spanning set. So R4 has a dimension 4. It's a 4-dimensional space, right? So you have to have minimum of 4 number of vectors, and if those 4 form a basis, sorry, if those 4 span R4, then those 4 will definitely form a basis for R4. Okay, so the answer to the question is option C. Any questions? If not, we will stop here. And okay, yeah, go ahead. Which question? If we have time, so we will do today. If it's a like very simple question, gate 2004. Okay, then I don't have access to those files. If you tell the question, I can either explain today or maybe in the next class, next Tuesday. So can you send that question to me? So this is my mail ID. Yeah, this is my mail ID. KRISHNANK@iac.ac.in. krishnank@iac.ac.in. Can you send that, Gobinath? Yeah. Okay. Then we will meet again next Tuesday, 6 to 7. Thank you. Have a good day.